Welcome to 9.5, the second part. Now we're dealing with systems of inequalities. All right, so we're going to graph the solution set of each of these systems. So what is a solution set? It's the intersection of the solution sets of the individual inequalities. So basically we're looking for where is the overlap between the multiple inequalities going to occur. All right, so if we look at our first example, I want you to try it on your own based on what I have over on the right. So x plus 2y is greater than 4, and 2x minus 3y is less than or equal to 12. Both of these are in standard form. Remember, dashed versus solid, okay? And then we have to talk shading, but don't shade until the very, very end. And you want to shade where the two inequalities will overlap in terms of the shading. So give it a try, see what you remember, and we'll come back. Okay, so this top inequality is in blue. I can graph my intercepts because it's in standard form. So 0, 2, and 4, 0. It's a dashed line, all right, because it's strictly greater than. I can test the point 0, 0. It happens to be false. 0 is not greater than 4, so I'm going to be shading to the right. Notice how I made little red arrows here, okay? The green is this second inequality. Again, we can graph those intercepts, 6, 0, and 0, negative 4. This guy is going to be solid. All right, it's going to be solid because it's less than or equal to. We can test the point 0, 0. When I plug 0 in for x and y, I get 0 is less than or equal to 12, which is true. So I'm going to shade in the direction of that point. So now I look at where is the overlap? Where are the arrows all pointing to? So we should see that the overlap, both arrows for both lines are pointing to this region here. That's where the overlap, that's what they have in common. So we go ahead and we shade in this region, and any point within this region is a solution to this system of inequalities. Looking at this next example, what I want you to notice is this guy right here. That's like saying negative 2 is less than x, or we could rewrite it as x is greater than negative 2, and x is less than 4, okay? So what we should notice is that these are vertical lines. X equals negative 2 is how we can think about it, and x equals 4. But because they are greater than, strictly less than if we go to the original, I'm going to have dashed boundaries. So again, these are vertical lines at x equals negative 2 and x equals 4, but because it's strictly less than all the way through, we've got dashed boundaries. Y is greater than or equal to negative 1. Hopefully we recognize that that is a horizontal line. Since I'm graphing greater than or equal to, I'm going to be shading above. With this guy here, since x is between negative 2 and 4, I'm going to be shading between those two blue lines. But where does the overlap occur? It occurs above the green line and between the blue. So my solution set is this shaded region here. Okay, I want you to try C on your own. Go ahead, plot. These are in slope-intercept form if you think of them as y equals 3x plus 1 and y equals 3x minus 4. All right, this top one goes through the point 0, 1 with a slope of 3. This guy goes through 0, negative 4 with a slope of 3. Go ahead, graph it, and see where the solution set lies. Okay, what you should have gotten is this top inequality is my blue dashed line here. All right, passes through 0, 1 with a slope of 3. If I were to test the point 0, 0, okay, it's just under this line here. We should be able to see 0, 0, 0 is greater than 1 is false, so we'd be shading to the left of the blue line. Our green line, again, is dashed, passes through the point 0, negative 4 with a slope of 3. All right, if I test the point 0, 0, we get 0 is less than negative 4, which is false again, so that means we're going to shade to the right of our line. So where does the overlap occur? Well, these are parallel lines. They each have a slope of 3. The blue line shading to the left, the green line shading to the right. There is no overlap. So since there is no overlap, we would say no solution. finally, with part D, we should recognize this first inequality is a line in slope-intercept with the y-intercept of 0, 7. Our slope is 2. All right, so you should be able to graph that. This second one is a quadratic, so you'll have to find your vertex. You can see a little bit of it. I got the vertex to be 0, -1, opposite of b over 2a, okay? And so our b value is 0, so the x value is 0. When you plug 0 in for x, you get the y value to be 1. Go ahead, plot both of these, see where the overlap occurs, come back and check. Okay, so hopefully you were able to graph the line okay. 0, 7 is my y-intercept, up 2 over 1 or down 2 over 1, and it's going to be a solid line. I'm going to test the point 0, 0. So when y is 0 and x is 0, we get 0 is less than or equal to 7, which is true. So we're going to shade to the right. I just marked that with the arrows. Okay, our quadratic here. Vertex is 0, 1. We pick points that surround it, and we get our other y values here. So hopefully you were okay graphing that. It is a dashed boundary. Make sure you extend it enough so that they intersect. So I really should have extended my blue line a little bit, as well as my parabola. Okay? All right. So now again, we can test the point 0, 0 because it's not on our parabola. 0 is greater than 1. Well, 0 is not greater than 1, so it's false on the outside. So we would be shading on the inside of our parabola. So where does the overlap occur? Well, it occurs inside of a parabola, but to the right of our line. So it is just this portion right here. If you have any questions on systems of inequalities, make sure you ask in class.